Hi class, this is my video for lesson 48. By now, hopefully you've completed 46 and 47. So Wednesday, I'm going to post 48 and 49 today, and I'll probably get 50 up there tomorrow morning. Hopefully you've also completed test 9 and watched my review before you did that. For some of you, I have a lot of checked homework here. I'm going to stick it in an envelope and mail that out. Hopefully you'll receive that by Friday or Saturday. I want you to have your checked homework back. And I'll be working on the homework I've gotten this week. So, okay, so this lesson is about fractional parts of a number. So when we talk about fractions, we know that we can, at least with a drawing, we can represent one whole. I have a rectangle here, represents one whole. And then I can take that same size. Imagine that this is actually like the same size. It's a little off because I'm a little sloppy when I draw. But if that were the exact same size, I can take that and divide it into 5 equal sections, and I would call each of my sections 1/5. So if my whole number is 1, if the rectangle is represented by 1, then when I divide it into 5 equal groups, it's going to be a fraction. It's going to just be part of 1 or less than 1. So I could, like, for example, I could X 2 of them off, and then I would call that 2/5. Okay? Now, if my rectangle were to represent a number greater than 1, if it were to represent, say, 175 here, and I divided that into equal groups, I would not have a fraction. I would have some whole number. In this case, I would have 25. Okay? I would have 7 equal sections here, this rectangle, 7 equal sections, and 175 divided by 175 divided by 7 is 25. So I represent that with a rectangle divided into 7 sections, and each one is worth 25. So if I were to X off 2 of those, probably should use fifths, 5 sections, but never mind. If I were to X off 2 of those, that wouldn't be called 2/7. In this representation, that would be equal to 50. Okay. If I were to mark off 3 of them, it wouldn't be 3/7, it would be 75, and so on. All right. So those drawings depict fractional parts of numbers. The one we're used to dealing with is fractional parts of the number 1. But we can also take fractional parts of numbers that aren't 1, in this case 175. And when the book presents this problem to you, it doesn't always say, what is 1/2 of 10? Or what is 1/3 of 9? It sometimes gives you a word problem, and you have to find out not the, say, the product, but you have to find out what the fraction is. In fact, in any of these fractional number problems, there's always 3 numbers in the equation. So using my depiction here as an example, I would say 3/7 of 175 is 75. Okay, so there's 3 numbers here, and in the practice problems they give you, at times they'll want you to find the fraction, at times they'll want you to find the whole, the value of the whole, and at times they'll want you to find the fractional part of the number. All right, and that ends up being 75. So I have examples down here of what these are going to look like, right, in your practice problems. They may say something like, what fraction of 175 is 75? Or they might say 3/7 of what number is 75? Or the third way they'll phrase it is 3/7 of 175 is what number? So the hardest part is reading this word problem and making it into an equation you can solve. Once you get to that point, that's the hardest and actually the most important part. It should be fairly easy after that. So let's look at number 1. Actually, let's look at all 3 of them and notice that each of these word problems contains the word of. Okay, and they also contain the word is. This is a clue for you on how to set up your problem. So wherever we see the word of, okay, that is going to be multiplication. And wherever we see the word is, I'll draw an arrow, that's going to be equals. Okay, so that helps you to know how you're going to set this problem up. So let's look at number 1. What fraction of 175 is 75? Let's set that up. Let's call the missing number in each problem, we'll call it m. I'm going to be looking for m. That's my variable. So looking at number 1, what fraction, we know that of is times, of 175 is, we know that's equals 75. So what fraction? I'm looking for the fraction, I call it m. That's how I set up problem number 1. Problem number 2, they give us the fraction. They say of, that's multiplied by, and then what number, that's my variable, and then they give me is, that's equals, and I have the answer. Okay, so you can see already the only option left is to be looking for the answer, and that's going to be m. So our last equation would look like this: 3/7 of, that's multiplied by 175. Then we come to the word is, that means equals, and then what number, there's my variable, m. So you'll come to the practice, and I think they actually ask you one of each. You're going to have to read these word problems. You're going to have to know, okay, when you see the word of, make that multiplication. When you see the word is, that means equals, and you just translate that right into your equation, okay? And then the missing number is, you can call it m or l, whatever you want, any variable name. Then you have to solve it, all right? So let's get to solving these. All right. To solve these, you're going to use some of the rules for your algebra equations that we learned a few lessons ago. Let's see. I'm going to make some room up here. I'm going to solve them up here. So let me take m. Now, I have m in my first one here. I have m times 175. I'm just going to write m and 175 next to it, okay? Because when a variable is next to a number, that means or implies multiplication, and that equals 75. For any algebra equation, I want to get my variable alone on the left-hand side, and I want to get my values over on the right-hand side. So I need to get m all by itself. Okay, we have m times 175. Using the division rule for equations that you learned a lesson or two ago, a few lessons ago, we can divide this by 175. So long as we divide the other side by 175, our equation remains equivalent, remains equal. It's a true equation, let's just say. Now I can cancel this, and I end up with m equals 75 over 175. I'm going to divide top and bottom by 25. So 25 goes into 75 3 times, and it goes into 175 7. So, you know, this obviously is correct. We've already worked this problem over here. I already know what all three of my values are. I'm just showing you how to work it out. Okay? So don't forget, your multiplication and division rules for equations, that's how you're going to get your variable all by itself, okay, on the left-hand side, and then you want a value on the right. That's the format you want your equation in. Okay, let's go to the next one. 3/7 times m equals 75. I'm going to rewrite this 3/7 m equals 75. It's less bulky to look at. Now I'm going to use the multiplication rule for equations, and I'm going to multiply this by its reciprocal, because that's going to cancel the 3/7, and I'll be left with m all by itself on the left-hand side, which is what I want. But if I multiply the left-hand side by 7/3, I have to do that on the right as well. So this is going to cancel. We know we can cancel numerators and denominators. So once that's all gone, I only have m now left on the left-hand side. This is going to give me, if I put that over 1, I can multiply my fractions. 75 times 7 is 525. And on the bottom, I just have 1 and 3. That multiplies to 3. And I'll give you one guess what 525 divided by 3 is. Okay, it's going to be this number here. All right. Are you starting to get the hang of what to do when you want a variable all by itself? Okay, this is real standard algebra you're doing here. These are algebra equations. The last one's very simple. It's what you're used to seeing. Okay, you're used to seeing two values on the left, something multiplied together, divided, added, or subtracted, and then you have to find the answer. So again, I'll put this over 1, 3 times 175 there. My numerators come out to 525. If I divide that by 7, again, one guess what that comes out to be. It's 75. So I know some of you are going to get stuck on how to solve some of these. The number third type problem everybody's used to seeing. I know how to multiply 3/7 by 175. But people tend to get stuck when they see something like this. Oh my gosh, I have to solve for a number that's not on the right-hand side. I have to do some division. This is classic algebra, okay? Or this equation here, classic algebra. Your job is to get your variable on the left-hand side all by itself and get all the numbers to the other side using the multiplication and division rules for equations. I would suggest you just come back and watch this video again, okay? That is the entirety of this lesson. I think let's see. Yep. I've actually shown you exactly what they're going to ask you in the practice, okay? And then I'm going to clear my canvas here. On test 9, hopefully you've taken it already, you're going to have a problem, or you probably should have taken it already. This is one thing I didn't go over. You had something like mn plus m, and they wanted you to evaluate that where m is 5 and n is, say, 12, right? To me, this seems pretty straightforward, but I'm going to just give a quick review here. This is a super simple type of problem. You take that number 5, you stick it there, and you take your value for n and you put it right there. What happens when I do that? All right, I'm going to replace m with 5, n with 12, and m again with 5, and I have to solve that. When I have two variables next to each other, that implies multiplication. There we have it. There's my equation. 5 times 12 plus 5. Okay, we're going to do our multiplication here. That's 60. I'm going to add 5 to it, and that evaluates to 65. I just wanted to do one of those quickly because I didn't do that for you in my review, but I was kind of hoping, it wouldn't confuse you guys too badly. Okay, so I'm signing off. Watch it again if you get confused, okay? Take care.